students, welcome to Civil Engineering and Programming channel. After a long time I am making a video on design of rectangular footing. Okay, let us click on this rectangular footing push button. Just then you'll get like this. Then you can see how you select the rectangular footing. Then this is the a pop-up window. You can see there are a lot of inputs. Okay, just let me before going to design this rectangular footing, we can go for design considerations. You can click on this design consideration too. Then you can see here design considerations for square footing for rectangular columns and vice versa. For rectangular columns, economical design of footings is obtained if the projection of footing from the face of the column in both direction is same. Okay, this is the projections from all the directions is same. Okay, the design is similar to that of square footing for square column, and same reinforcement is provided in both the directions. Mostly the same reinforcement is provided in both the directions. Okay, please remember rectangular rectangular footing and rectangular column, we have to place the depth of the footing parallel to the length, that is length of the footing, that is length of the rectangular footing, to get the economical design. Okay, okay, this is all about little bit of theory. You can see here this is one critical section for bending, and this is the critical section for two-way shear and one-way shear, that we can call it as a punching shear. These are some of the bending moment along longer direction and bending moment along shorter direction. Okay, bending moment along longer direction, we have to multiply QU into shorter direction, that is width of the footing, into L minus A square by 8, or WL square by 8, something like that. The bending moment along shorter direction, QU, that is earth pressure, into L. L is longer length of the footing, rectangular footing, into B, width of the footing, minus B square by 8. Okay, these are some bending moment considerations for longer direction and shorter direction of the particular footing. Okay, let us first click on this grade of concrete. I am taking as 30, then grade of steel as you can 550. We can select the axial service load, let us say 50 tons, that is 500 kilonewton, and SBC of the soil I am assuming as black cotton soil, 150 to 200 kilonewton per meter square, so I am taking 200. The width of the column I am taking has the rectangular column. Okay, width of the column is 300 and depth of the column is 450 mm. Okay, depth factor, what is mean by depth factor means what we get the d effective, we have to double or triple according to our criteria, design criteria. So I am taking as 2.5 depth factor, and diameter of the main bar I am taking 2 in main direction, and the distribution I am taking as 10 mm. Clear cover obviously 60 mm, 50 mm to 70 mm, we can take between that depending upon the conditions of the site. Okay, then just you click on the start design. This, you can see here area of the footing. If you want to provide a square footing, then you have to square root of the 2.75 you have to provide. So I want to design the rectangular footing, so I want to first fix the width of the footing. Width of the footing is 1.2 meters. Okay, then okay, then you can see a not safe with respect to one is increase the depth of the footing. Therefore we have to increase the depth of the footing. Therefore what we have to do is just refresh all, just you depth of the factor you change from 2.5 to 3. Okay, then again start design 2.75, again enter the width of the footing in meters, that is 1.5 meters, so 1.2 meters, then okay. Okay, not safe with respect to one measure, increase the depth of the footing. Again we have to increase the depth of the footing, and what we have to do is we have to increase the depth factor. What we have to do is we can take 4. Okay, then again to click on start design 2.75 and you enter 1.5, 1.4. Okay, just you click on, so you can see a footing is safe with respect to one way shear. Therefore we have to provide the depth of the footing is 467 mm. We can provide 500 mm as a depth of the footing. An axial service load for 50 tons. Then soil bearing capacity 200. Then main reinforcement we have to provide 12 mm at the rate of 300 mm center to center, and the distribution reinforcement is also we have to provide the same. If you require, you can provide the same 10 mm at the rate of 300 mm center to center, or you can provide 10 mm at the rate of 200 mm center to center. Okay, this is all about design of rectangular footing in Visual Basic 6.0. Okay, just if you want to refresh, just you refresh all. Okay, let me again, I want to axial service load is 60 tons, that is 600 kilonewton. Then just you start again, start design. Okay, area of the footing is 3.3. I am providing 1.5, 1.5. Then so footing is safe with respect to one way shear. Okay, we have to provide 504 mm. We have to provide the main reinforcement 12 mm at the rate of 300 mm center to center, and the distribution reinforcement as 10 mm at the rate of 300 mm center to center. Okay, our design is safe with respect to one way shear. Okay, this is all about design of rectangular footing in Visual Basics 6.0. Okay, anyway, thank you for watching this video. Thank you.